So given that, how did these executive orders from Biden on day one, how do they fit with his message from that inaugural stage of unity? When we talked to our colleague yesterday, Seth Herndon, about how deeply Joe Biden believes in bipartisanship, in working with Republicans, and that was the absolute core of his message. And so is signing these executive orders in conflict with that? And I ask that because several Republicans certainly see it that way.
Yeah, so I think you can look at that question through two different lenses, one philosophical and one pragmatic, right? So I think from a philosophical standpoint, President Biden would say this doesn't conflict with that message because so much of the substance of what his executive orders are trying to achieve is a rejection of the divisiveness of Donald Trump, right? So if you look at the immigration executive orders, he's trying to get the country back to a place where we're not pitting us against them, the insider against the outsider, us versus the other, right? Through that lens, it is not in conflict. But I think from the pragmatic side, a lot of the last 4 years, a lot of Republicans liked. They might not have liked everything, but in terms of the president's economic policies, in terms of his border security policies, there was a lot that Republicans liked. And I think that one of the things that President Biden is going to have to confront over the next, 100 days, let's say, is how much does the quick pace of these executive actions and the extent to which he's trying to quickly erase the Trump legacy, how much does that leave a bad taste in the mouth of Republicans, especially in the Senate where he's got a 50-50 split? He's going to need Republicans to pass any kind of big, broad agenda. And, a lot of them, as I think you hinted a minute ago, a lot of them won't see this as unity. They won't see this as unifying. They will see this as unilateral and acting without the kind of consultation and cooperation and compromise that is sort of part of his shtick. And so my sense is that as he pursues this goal of repairing the soul of the nation, kind of purging the last 4 years of divisiveness and anger, that, he will accept some cost to that. And some cost of that might be a political cost, and we'll just have to see.
So I want to zoom out for just a moment to this question we started with, which is this history of presidents using executive orders over and over again, and kind of where it's left us as a government. Because we now have a President Biden having reversed many of the actions of a President Trump in 24 hours. And so we've now entered a pretty clear cycle of one president using executive orders to theatrically wipe away the legacy of the last president. And is that any way to govern?
I covered Obama for 8 years and Trump for 4 years. And for most of that time, we've been locked in this cycle of impermanence, right? Where everything is temporary. Everything is a sort of quick reaction to what can I do quickly because I can't accomplish anything that's really substantive and that's really permanent. And look, the only thing that is permanent in our way of governance is if you can get a big piece of legislation passed through the House, through the Senate, with bipartisan majorities where there's an actual consensus among the people who are our representatives, and then signed by the President of the United States. And if you can get that, that can be a permanent, lasting legacy, which lasts generations. If you don't, then we're locked into what we've had now, where businesses have trouble knowing kind of what the roadmap is. The countries around the world don't know who to believe in terms of which way the United States is going, because it could go one way one day and the other way a different day. And I think that's where we are right now.
Right, just to highlight the point you made, I think of the Affordable Care Act, for example, passed into law by the House of Representatives, the United States Senate, signed into law by President Obama. There have been dozens of efforts to repeal it, to chip away at it, to sue it out of existence. But because it's a law, it has pretty much remained with modification in place since it was passed 10 years ago. That is probably going to be true for several of the pieces of legislation that Donald Trump passed. His tax cuts, for example, or his criminal justice reform.
Absolutely. I was there at the White House the night that the Affordable Care Act passed. I remember it feeling like a historic moment, a permanent moment. And I think the question for Joe Biden and the thing that he sold to voters is that he'll get us back there. He'll get us back to a place where, for example, he submitted an immigration overhaul bill to Congress on his first day saying, not only do I want to do these executive orders, but I want the Congress to come together and say, let's design a new immigration system for the country. And we'll see. I mean, that's been tried for decades and the country hasn't been able to get there. But
he sent it to Congress, so we know that he wants a legislative solution, not just an executive order.
Right. And the question is, can he deliver it? Can he help get us past this place in American politics that we've been for, these last number of years where those kinds of big things get jammed up and don't go anywhere? And if he can, then, that legacy will be a whole lot longer lasting and will be much harder for the next president to unravel because it'll not just be another executive order that can be wiped away with a pen.
Right. It will be law.
Yeah, exactly.
Thank you, Mike. We appreciate it.
Sure. Happy to do it.
We'll be right back.
This year, we've all had to juggle our schedules like never before. And for those looking to advance their education, finding a program that adapts to an ever-changing routine may seem out of reach. The reality is that you can earn a respected degree online from a university designed to work with change. For over 20 years, WGU has helped similar students earn their bachelor's and master's degrees. With no set login times and 24/7 access to most coursework, earning your degree is more than doable. Visit wgu.edu/New York Times to learn more.
Here's what else you need to know today.
Let me be very clear. Things are going to continue to get worse before they get better.
On Thursday, President Biden warned Americans that the death toll from the coronavirus would likely reach 500,000 by next month. The prediction came after the United States reported 4,367 deaths on the day of Biden's inauguration, one of the highest daily death tolls since the start of the pandemic. And the Times reports that Senator Mitch McConnell, the Republican minority leader, plans to ask Democrats to delay the start of President Trump's impeachment trial until February to give Trump's lawyers time to prepare a defense.
I don't think it's very unifying to say, oh, let's just forget it and move on. That's not how you unify.
During a news conference, House Speaker Nancy Pelosi defended the plan to pursue a trial in the Senate and rejected claims from Republicans that it would detract from Biden's calls for unity.
And just because he's now gone, thank God, you don't say to a president, do whatever you want in the last months of your administration. You're going to get a jail card free because people think we should make nice and forget that people died here on January 6th. I think that would be harmful to unity.
Today's episode was produced by Sydney Harper and Eric Krupke. It was edited by Lisa Chow and engineered by Chris Wood. That's it for the Daily. I'm Michael Babar. See you on Monday.
Traditional Medicinals looks to the earth for all her healing gifts. They believe that plants can do some pretty amazing things. That's why they use medicinal-grade herbs like echinacea, eucalyptus, and ginger in their teas to help soothe and support your body naturally. Every which way we turn, Mother Nature is there to remind us that she's got our back. Visit traditionalmedicinals.com and use code NYT20 to see what makes their teas so incredible.
over 25, or we could call it 11/25, to see if we can write that as a decimal. And we're going to round it to the nearest thousands place. And so another way of viewing this, 11 over 25, this is the same thing as 11 divided by 25. So we can literally say, we can literally divide 25 into 11, and whatever we get, that is going to be the decimal representation of 11/25. And since we're going to go into into the places less than the ones place, we're going to go into the tenths place and the hundredths place and the thousandths place. Let's add some zeros to this 11 right over here after the decimal. And now let's start to divide. 25 doesn't go into 1. 25 doesn't go into 11. 25 does go into 110. So when 25 goes into 110 4 times, 4 times 25 is 100. So it goes into it 4 times. Let's keep the decimal up here. So we'll write 0.4. 4 times 25 is 100. And now we can subtract 110 minus 100 is 10. And now we can bring down another 0. 25 goes into 100 exactly 4 times. 4 times 25 is 100. And then you subtract and you get 0. So we actually didn't even have to round this one. This fraction is exactly 0.44.
Quality writing makes your schoolwork better and helps you stand out in the process.
In this video, we're going to focus on how to add, subtract fractions, how to multiply, divide them, how to convert improper fractions to mixed numbers. Basically, almost everything you need to know about fractions. So let's begin. So let's say if you want to add these two fractions, 7 over 5 and 1 over 4. How would you do it? Well, here's one quick and simple technique. You can multiply 5 and 4, which will give you 20. And then next, multiply 7 times 4, which is 28. And then add that to 5 times 1, which will give you 5. So 28 plus 5, that's 33. And divided by 20. Let's try another example. So whether you're adding or subtracting, you can use the same technique. So let's say if you want to subtract these two numbers, 3 over 4 minus 2 over 7. Multiply the two numbers on the bottom. 4 times 7, that's 28. And 3 times 7 is 21. And then 4 times 2 is 8, but there's a minus sign between them. So in this case, this is going to be 13 over 28. But now, that's not the only way that you can combine two fractions. Now, we're going to go over the same problem, but using a different technique. Now, notice that you have a 4 here. What you can do is multiply this fraction top and bottom by 4. And for this one, multiply the first fraction top and bottom by this number, 7. 3 times 7 is 21, and 7 times 4 is 28. 2 times 4 is 8, and that's also 28. And so you can get the same answer. Now, once you have the same denominator, you can now add the denominators. In this case, subtract. 21 minus 8, that's 13. So that's another technique in which you can get the same answer if you want to add or subtract two fractions. But now let's say if you want to combine 3 fractions. let's say if you have 1 over 3 plus 2 over 5 minus 3 over 4. Now, the first technique won't really be useful in this example, or it might be quite confusing. The second technique will be very helpful. What we need to do is figure out the least common denominator, which is basically all of them. You need a 3, a 5, and a 4. Now, this fraction has a 3, but it's missing the 5 and the 4. So we're going to multiply top and bottom by 4 and by 5 at the same time. Now, for this fraction, it has the 5, but it's missing the 3 and 4. So we're going to multiply top and bottom by 3 and by 4. And for this one, we need to add a 5. And we're missing, we have a 4 already, but we're missing a 3. The goal is to make sure that the denominator of every fraction is identical. So 5 times 4 is 20, and 20 times 3, if 2 times 3 is 6, 20 times 3 is 60. Every fraction will have the same denominator, and that is 60. So now, what we're going to do is multiply the numerators. 5 times 4 is 20. And for the next one, let's see. 4 times 2 is 8. And then 8 times 3, that's 24. 3 times 5 is 15. And 15 times 3, that's 45. Or you can do 3 times 3, which is 9. 9 times 5 is 45. Either way, you get the same answer. Now, if we have the first two numbers, 20 plus 24, that's 44. And then if we subtract 44 by 45, we get negative 1. So that's the answer for this example. It's negative 1 over 60. But for the sake of practice, let's try another example. So let's say if we wish to add 2 over 3 plus 1/2 minus 3/4. So the common denominator, we need a 3, a 2, and a 4. So the common denominator is 3 times 2 times 4, which is 24. So for this fraction, it's the first one, it's missing 4 and a 2. So let's multiply top and bottom by those numbers, 4 and 2. Okay, this one has a 2, but it's missing the 3 and 4. So let's multiply top and bottom by 3 and 4. Whatever you do to the top, you have to do to the bottom. And this one, it has the 4, but it's missing these 2. So we know we have a common denominator of 24. Okay, so now let's do some math. 2 times 2 is 4, times 4, that is equal to 16. Here, 4 times 3, that's 12. And 3 times 3 is 9, times 2, that's 18. So 16 plus 12, that's 28. And 28 minus 18 is 10, so we get 10 over 24. But we have a fraction in which both numbers are even, which means that we can reduce this fraction. If we divide top and bottom by 2, we can get this. Half of 10 is 5, and half of 24 is 12. So the final answer for this example is 5 over 12. So that's how you can add or subtract 2 or 3 fractions. Let's try this one. Let's say if you have 5 divided by x plus 2 over 3. So the common denominator is basically these two combined, 3x. So let's multiply this by x and this side by 3. So then 3 times 5 is 15, and here we just get 2x. So at this point, once you have the same denominator, you can combine this into a single fraction. But we can't add 15 and 2x because they're not like terms. So this is the final answer for this example. Let's try another example in which we have variables. So let's say if we wish to subtract these two. let's use the first method that we went over. So the common denominator is going to be x times y. And here we have 7 times y, which is 7y, and 2 times x. And that's pretty much all we could do for that problem. Try this one. 3 over x plus 4x plus 1 divided by x squared. Now, our goal is to make sure that the denominator is the same for both fractions. We don't have to really adjust the second fraction. Notice that if we multiply the first fraction by x, we're going to have the same denominator. It's going to be 3x over x squared plus 4x plus 1 over x squared. Once these two are the same, we can write this as a single fraction, which is going to be 3x plus 4x plus 1 divided by x squared. And here we have like terms, so we can add those two. 3x and 4x is 7x. So it's 7x plus 1 divided by x squared. But now let's say if you want to multiply two fractions. Say if you have 4/3 and you wish to multiply it by 5 over 7. What you need to do is multiply 4 by 5. You multiply across. 4 times 5 is 20, and 3 times 7 is 21. And that's all you gotta do if you want to multiply two fractions. Now, be careful though. Let's say if you have two fractions separated by an equal sign, and you wish to solve for x. You don't want to multiply across. If you have an equal sign, you want to cross multiply. 5 times x is 5x, and 3 times 9 is 27. And then you can solve for x by dividing both sides by 5. So x is 27 over 5. So whenever you have two fractions separated by an equal sign, you cross multiply. But if you're multiplying two fractions and there's no equal sign between them, then you can multiply across. Now this one, instead of multiplying 12 by 18, you don't want to do it that way because you're going to get a big number. And you don't want to multiply 27 by 30. So if you want to multiply two fractions, and if you're dealing with large numbers, break it down first. 12, you can write 12 as 6 times 2. 27 can be written as 9 times 3. And 18, you can write that as 9 times 2. And 30 is 6 times 5. Notice that we can cancel 6, and we can cancel a 9, which makes our lives a lot easier because you don't have to simplify at the end. So now we can multiply the 2's. 2 times 2 is 4, and 3 times 5 is 15, and that is the answer. But now, what would you do if you had this example? 15 divided by 40 divided by 35 over 56. Feel free to pause the video for each of these examples, try it yourself, and then unpause it when you're ready. So how can we divide two fractions? There's something called keep, change, flip. You keep the first fraction exactly the way it is, and then you change division to multiplication, and then you flip the second fraction, 56 over 35. So 15, we can break that into 5 and 3. 40, we can write that as 8 times 5, and 56, that's 8 times 7, and 35 is 7 times 5. So we can cancel an 8, we can cancel 5, and we can cancel 7. So all we're left with is 3 over 5. And that's it for that example. So try this one. Let's say if you have 28 over 24 divided by 32 and 35. So first use keep, change, flip. Keep the first fraction the same. Change division to multiplication. And then flip the second fraction. And then instead of multiplying 32 by 28, simplify it. Or break down these large numbers into small numbers. 28 is 7 times 4. 24 is 8 times 3. 32 is 8 times 4. And 35 is 7 times 5. So we can cancel a 7. We can get rid of an 8. And that's about it. So now we can multiply 4 by 4, which is 16, and 3 and 5, which is 15. So what would you do if you have an example that looks like this? 8 divided by 3 over 4. How would you solve this one? If you see something like this, the whole number 8, you can write it as 8 over 1, and then basically solve it the way we did it. So keep the first fraction the same, change division to multiplication, and then flip the second fraction. So there's no point in breaking down 8 into 4 and 2 because you can't really cancel with the 3. So all we can do here is multiply 8 and 4, which is 32, and then 1 and 3, which is 3. And that's it. So it's only useful to break this number down into small numbers if you can cancel something. If nothing can be canceled, there's no point. So try this example. 5 over 7 divided by 6. So let's write this as 6 over 1, so that's 5 over 7 times 1 over 6. 5 times 1 is 5, and 7 times 6 is 42. And that's the answer for that example. So what if you see something like this? How would you simplify this problem? If you have a fraction or two fractions within a bigger fraction. Well, what this really means is you have 5/3 and it's divided by 7 over 6. So you can rewrite it this way. And then you know how to solve this problem. Just use keep change flip. Now for this example, we can rewrite 6 as 3 times 2 because we can cancel the 3's. And so then it's 5 times 2, which is 10 over 7. And that's it. The answer is 10 over 7. But now let's say if you have this problem, 4 plus 2/3 and 5 minus 1/3. What would you do in this situation? So here we have a complex fraction. In a situation like this, multiply top and bottom by the common denominator, which is basically 3. So 3 times 4 is 12. And then 3 times 2/3. If you multiply 2/3 by 3, or 3 over 1, the 3's cancel, and you just get 2, this number. So plus 2. And then 3 times 5 is 15. And then 3 times 1/3, the 3's cancel, so you just get -1. So 12 plus 12 is 14. And 15 minus 1 is 14. 14 divided by 14 is 1. And that's a nice answer for a problem like this. So now it's your turn. Try this one. 7 plus 3/4 and 9 minus 4/5. So now we have two different denominators. We got a 4 and we have a 5. So what you want to do is multiply top and bottom by 4 and at the same time by 5. So, or by 20. 4 times 5 is 20. So if we multiply 20 by 7, if 2 times 7 is 14, 20 times 7 is equal to 140. And here we have 20 times 3/4. The 4's cancel. So what we have left over is 3 times 5, and that's 15. And then here 20 times 9. 2 times 9 is 18, so 20 times 9, if you have 9 $20 bills, that's 180. And then 20 times 4/5. The 5's cancel. And now we have 4 times 4, which is 16. So 140 plus 15, that is 185. And 180 divided by 16 is 164. And it doesn't look like we can really simplify this. At least I don't think so. So I'm going to leave the answer like that. Try another one. Feel free to pause the video and try to simplify this. So let's multiply top and bottom by 3 and by 4. So 12 times 8, that's equal to 96. And then 12 times 5/3, the 3's cancel, so we just have 5 times 4, and that's 28, but there's a negative sign in front. And then 12 times 4, that's 48. And then 12 times 1/4, 4's cancel, so we just have 1 times 3, which is 3. 96 minus 20, that's 76, and 48 plus 3 is 51. And you can't really simplify it, so that's the answer. Now let's say if you have an improper fraction, 23 over 5. How can you convert it into a mixed number? I'm going to show you 2 techniques. One way you can ask yourself, how many times does 5 go into 23? 5 goes into 23 4 times, because 5 times 4 is a number that's less than 23. 5 times 4 is 20. And then you take that number, subtract it from 23. 23 minus 20 is 3. And then the denominator will always be the same. If there's a 5 on the bottom, it's going to be right here. So 23 over 5 is 4 3/5 as a mixed fraction, or a mixed number. So let's say if you have 14 over 9. How many times does 9 go into 14? 9 goes into 14 once, because 9 times 1 is 9. The denominator will stay the same. And then 14 minus 9 is 5. So try this one, 28 over 6. So how many times does 6 go into 28? 6 goes into 28 4 times. 6 times 4 is 24, which is less than 28. But 6 times 5 is 30, it's too much, it's greater than 28. So you want to find pretty much the highest multiple of 6 that goes into 28. So 6 goes into 28 4 times. The denominator will stay the same. And 28 minus 24 is 4. But you can reduce that. 4 over 6, if you divide both numbers by 2, that becomes 2/3. So this is 4 2/3. So that's one way you can do it. Another way, let's say if you have 17 over 5. Think of the highest multiple of 5 that's just under 17. That's 15. So you can break down 17 into 15 plus 2. Now 15 divided by 5 is 3. And when you have this 3 2/5, that's basically 3 2/5. Here's another one. Let's say if you have 29 over, let's use 7. So the highest multiple of 7 just under 29 is 28. You have 7, 14, 21, 28. So 28 plus 1 is 29. Why would it like that? And then 28 divided by 7 is 4. So this is 4 1/7. Now let's say if you have a mixed fraction and you want to convert it to an improper fraction. How can you do that? Well, first, keep the denominator the same. And for the numerator, multiply these two numbers. 3 times 3 is 9. And then add this number 2. And so this is 11 over 3. So try these examples. 5 1/4. 7 3/8. And then 2 4/5. So keep the denominator the same, 4. And then multiply 4 times 5, which is 20. And then add this number. So this is equal to 21 over 4. So the denominator is going to be 8. 7 times 8 is 56, plus 3. So we're going to get 59 over 8. And for this example, the 5 is going to stay the same. 2 times 5 is 10, plus 4. So this is equal to 14 over 5. So let's say if you wish to add 2 mixed fractions. Let's say if you want to add 3 1/4 plus 5 2/3. How can you do it? Well, the first technique that you can use is just, you can convert it into an improper fraction. So the denominators will stay the same. Here we have 3 times 4 plus 1. 3 times 4 is 12 plus 1, that's 13. 5 times 3 is 15 plus 2, that's 17. And at this point, we can use the methods that we learned earlier in this video. Let's use the first method. 4 times 2 is 12. 3 times 13, that's 39. And 4 times 17, that's 68, I believe. And if we add these two, 39 and 68, that's like 170. No, not 117. 107. 107 over 12. And then if you want, you can convert that into a mixed number. Let's see, how many times is 12 going to 107? I know that 96 is a multiple of 12. And 107 minus 96, that's 11. 96 divided by 12, that's 8. So this is, as a mixed number, 8 and 11 over 12. Now there's another way that you can add those two numbers. 3 and 1/4 plus 5 and 2/3. We need to realize this 3 and 1/4 is basically 3 plus 1/4. And 5 and 2/3 is 5 plus 2/3. And then you can add these numbers, 3 and 5. That gives you the 8 right there. And then add these two fractions separately. So 1/4 plus 2/3. Let's use the first method. 4 times 3 is 12. And then 3 times 1 is 3. 2 times 4 is 8. So that's basically 11 over 12. So this is 8 and 11 over 12. Try this example. 4 and 3/4 minus 3 and 1/5. Actually plus 3 and 1/5. So I'm going to write it as 4 plus 3/4 plus 3 plus 1/5. So I'm going to add these two. 4 and 3, that gives me 7. And then I'm going to combine these two fractions using the first method that we covered. So 4 times 5 is 20. 3 times 5 is 15. And then 4 times 1 is 4. So that's 19 over 20. So then we can write it as 7, 19 over 20. Try this one. 5 and 2/7 minus 3 and 3/4. So if you want, you could convert these into an improper fraction. Or you can do it this way. 5 plus 2/7 minus 3 plus 3/4. You gotta distribute the numbers for this to work. So what we have is 5 minus 3. And then plus 2/7 minus 3/4. Make sure you distribute the negative signs to both of these numbers. So 5 minus 3 is 2. And if we combine these two, it's 7 times 4, which is 28. And then 2 times 4, which is 8. And 7 times 3, which is negative 21. So that's 8 minus 21, that's negative 13. Maybe this method probably wasn't the best one. So now we have 2 plus negative 13 over 28, which we can't really combine that as of yet. So we're going to have to get common denominators for this example. So 2 over 1, that's like, if you multiply top and bottom by 28, it's 56 over 28 minus 13 over 28. So 56 minus 13, that's 43. So we have 43 over 28. And if we're going to convert that back into an improper fraction, that's 28 over 28 plus 43 minus 28, that's 15. Now this, you can convert this into 1. So this is 1 and 15 over 28 as a mixed number. Now let's see if you want to multiply two mixed fractions. How can you do it? The best thing for this one is just to convert it into an improper fraction. So the best thing for this one is the denominator is going to stay the same. The numerator, it's going to be 7 times 4, that's 28 plus 1, so that's 29. Here, 3 times 5 is 16 plus 2, that's 17. And for this, I'm going to use a calculator. So now, what we have to do is multiply it times 29 times 17, that's like 493. 4 times 5, that's 29. And that's it. And if you want, you can convert that into a mixed number. But now, what would you do if you have to, like, divide by two mixed numbers? How would you divide them? Now, it turns out we covered an example like this. What you want to do is rewrite it as 5 plus 2 over 7 and 3 plus 1 over 4. And then simplify the complex fraction. So let's multiply top and bottom by 7 and by 4 to get rid of these denominators. So we're going to multiply 5 by 28. So it's easier if you multiply 5 by 4, which is 20, and then 20 times 7, which is 140. So now 28 times 2 sevens, the 7s cancel, and you should get 2 times 8, which is, 2 times 4, which is 8. And here, 28 times 3, it's easy if you do maybe 4 times 3, which is 12, and then 12 times 7, which is 84, if you know your 12 times tables. And then 1/4 times 28, 4's cancel, so we just get 7 times 1. So 140 plus 8, that's 148, and then over 91. But now let's say if you have a fraction and you want to convert that into a decimal, how can you do that? To convert fractions into decimals, you need to use log division. So we're going to put the 4 on the outside and the 3 on the inside. The numerator goes on the inside. And then we're going to add a 0. How many times does 4 go into 30? 4 goes into 30 7 times, but since it's not actually 30, since it's 3.0, we have to use 0.7. If 4 times 7 is 28, 4 times 0.7 is 2.8. And when you subtract these numbers, you get 0.2. So we're going to add a 0 and treat this as if it's 20. How many times does 4 go into 20? 4 goes into 20 5 times. And the remainder this time is 0, so it stops here. 3 over 4 as a decimal is basically 0.75. So let's say if you want to convert 4 and 2/5 into a decimal. This is basically 4 plus 2/5. What you really have to focus on is just this part and use log division. So let's put the 5 on the outside, the 2 on the inside. So 5 doesn't go into 2, so let's add a 0. How many times does 5 go into 20? 5 goes into 24 times. If 5 times 4 is 20, 5 times 0.4 is 2.0. And the remainder is 0, so that means 2 over 5 is basically just 0.4. So this is equal to 4.4 as a decimal. For the sake of practice, let's try one more example. Let's convert 3/7/8 into a decimal. And then we'll convert it to a percentage. So this is 3 plus 7 over 8. And let's use long division for 7 over 8. So let's add a 0. How many times does 8 go into 70? 8 goes into 70 8 times. 8 times 8 is 64, so 8 times 0.8 is 6.4, with a difference of 0.6. So if we add a 0, 8 goes into 60 7 times. So 8 times 7, that's 56. And if we subtract these two numbers, we get 0.04. And we're going to add another 0. So 8 goes into 40 5 times. And this time, the remainder is 0. So 7 over 8 is basically 0.875. So 3 and 7/8 is 3.875 as a decimal. Oh, by the way, 0.875 as a percentage, just multiply by 100 or move the decimal 2 units. So that's 87.5%. So like 3 over 4, which was 0.75, that's equal to 75%. just move the decimal 2 units to the right, and that's how you can convert a decimal into a percentage. Or just multiply 0.75 by 100, and you get 75%. So like 0.23 would represent 23%. 0.046 is like 4.6%. So convert these numbers into percentages. Let's say if you have 1.25, 0.68, 0.031, and 0.0015. As a percentage, this is 125%. This is 68%. This is 3.1%. And this is 0.15%. So that's how you can convert a decimal to a percentage. Just move it 2 units to the right. But now, how can you convert a decimal back into a fraction? So let's say if you have 0.2, how do you convert that into a fraction? Well, first put it over 1. And for this one, multiply top and bottom by 10. 0.2 times 10 is basically 2. 1 times 10 is 10. And then if you divide both numbers by 2, you get 1 over 5. So 0.2 is 1 over 5 as a decimal. So if you have 0.3, this is basically the same as 3 over 10. 0.4 is 4 over 10, but you can reduce that. If you divide by 2, this becomes 2 over 5. So try these. Let's say if you have 0.24, 0.25, and 0.36. Convert these decimals into fractions. So for this one, what you want to do is, since 4 is in the hundreds place, multiply top and bottom by 100. So this gives you 24 over 100. And then reduce the fraction. If we divide both numbers by 2, half of 24 is 12, half of 100 is 50. And then you can reduce that further into 6 over 25. So 6 over 25 is 0.24. So this is going to be 25 over 100. And if we divide both numbers by 25, you get 1 over 4, which is 0.25. This is 36 over 100. And if we divide both numbers by 2, half of 36 is 18, half of 100 is 50. And if we do it again, half of 18 is 9, half of 50 is 25. So what about these? 0.218 and 0.314. So this time, the last digit is in the thousands place. So we're going to multiply top and bottom by 1,000. So this is equivalent to 218 over 500. And to reduce the fraction, we're going to divide top and bottom by 2. Half of 218 is 109. And half of 500 is 250. And 109 is an odd number, so we can't divide it by 2. And it doesn't really go into 3, so we got to stop there. So this is equal to 314 over 1,000. You know what? I messed up. This is supposed to be 218 over 1,000. And then this is supposed to be 500. I think I jumped the gun on that one. Alright, let's work on this one. Half of 314, that's like 157 over 500. And we can't really reduce 157, so we'll have to stop there. But now sometimes you may get a decimal that repeats itself. So what do you do in a situation like that? Let's say if you have 0.2 repeated, this is like 0.22222, it goes forever. You need to know, you just got to commit this to memory, this is 2 over 9. 0.4 repeated is 4 over 9. 0.3 repeated is 3 over 9, that reduces to 1/3. Likewise, 0.23 repeated is 23 over 99. And 0.36 repeated is 36 over 99. And 36 over 99 can be reduced. If you divide both numbers by 3, you get 12 over 33. And you can reduce that further, which is 4 over 11. Likewise, if you have 3 numbers repeated, let's say like 0.126 or 0.315, this is 126 over 999 because you have 3 digits. And this is 315 over 999. It's just the way it works. let's see, if we divide both numbers by 3, this is 333. 126 divided by 3, I believe that's 42. And we can reduce that further by 3. And so we'll get 14 over 111. For this one, if we divide both numbers by 3, 315 divided by 3, that's like 105. And you could divide that further by 3. This will give you 35 over 111. But now, let's see if you have an example like this, 0.43, but only the 3 is repeated. So this is like 0.43333333, and it goes on forever. What would you do in this situation? You need to realize that 0.43 repeated is 0.3 repeated plus the number. If you take 0.433333 minus 0.33333, you get 0.1. So we know that 0.3 repeated is 3 over 9, and 0.1 is like, if you multiply top and bottom by 10, you get 1 over 10. So 3 over 9 reduces to 1/3. So now we just got to add these two fractions. So 3 times 10 is 30, and 1 times 10 is 10, and 3 times 1 is 3. So this is 13 over 30. And let me just confirm that with the calculator. If you type in 13 over 30 in your calculator, you should get this decimal value. So that's how you can check your work. Try this example. 0.6323 repeated. So first write the part that's repeated, which is 0.2323 ... And then take that number, 0.63232323, subtract it by 0.23232323, and then you'll get like 0.4. This is the element that's not repeated. So you want to subtract this number by the portion that's repeated, and then you get this part. So the part that's repeated, that's 23 over 99. The part that's not, you can multiply top and bottom by 10, so that's 4 over 10. So we have 23 over 99, and we can reduce this to 2/5. So 5 times 99, that's like 495. And 5 times 23, that's 115. And 99 times 2, that's 198. 198 plus 115, that's 313, I believe. Let me add that. And it doesn't look like we can reduce 313 over 495. And that's the answer for the example that we just worked on. So our final example for today will be this one. Let's say if you have 0.518, 313, or just 13 repeated. So we know that 0.5813 repeated is the sum of 0.13 repeated plus another number. So take 0.5813 and subtract it by 0.1313. So you want to make sure that you have, if you have 4 digits here, like 4 numbers after the decimal, subtract it by 0.1313. Make sure it's only 4 digits after the decimal. And you get the other number that needs to be added, the 0.45. So what we have here is 13 over 99 plus 45 over 100. Now, before you combine these two fractions, you want to reduce it. 45 over 100, we can divide both numbers by 5, so it's going to be 9 over 20. And now we can combine these two. 20 times 99. That's like 1980. And 13 times 12, that's 260. And 9 times 99 is 891. And then if we add 891 to 260, that's 1151 over 1980. And that gives you this decimal if you type it in your calculator. So, I mean, if you understand all the concepts that we went over regarding fractions in this video, I mean, it should be okay. I don't think there's anything else they need to know, but I mean, there might be other stuff, but that's pretty much it for this video. So thanks for watching and have a great day. This video is for those of you who want to improve your score in the math section of the GED exam. Now, for each of these problems, I recommend that you pause the video and try to work on the problem yourself. And then once you've done so, play the video and see if you have the right solution. So let's start with this one. Number 1. What is the perimeter of the triangle shown below? In order to calculate the perimeter of any figure, you need to add up all the sides of the figure. In this case, we have a triangle, so we need to add up the 3 sides of the triangle. However, we are missing one side of the triangle, so we need to find it. Now, you need to be familiar with something called the Pythagorean Theorem, which applies to right triangles. A right triangle is a triangle with an angle of 90 degrees, represented by the box that you see there. And here's the formula. A squared plus B squared is equal to C squared. C is basically the hypotenuse, the longest side of the triangle, which is always opposite to the box. A, in this case, is 6, and we're looking for the missing side, which we'll call B. So let's replace A with 6, and let's replace C with 10. 6 squared is 6 times 6, which is 36. 10 squared is 10 times 10, which is 100. Now let's subtract both sides by 36. 100 minus 36 is 64. Now to calculate B, we need to take the square root of both sides. The square root of 64 is 8. And so that's going to be the missing side left. So let's write B is equal to 8. Now that we have the missing side left, we can calculate the perimeter, which is the sum of the 3 sides of the triangle. So it's A plus B plus C. A is equal to 6, B is 8, C is 10. Now 6 plus 8 is 14, and 14 plus 10 is 24. And so that is the perimeter of the triangle shown below, which means D is the right answer choice. Number 2, multiply. So here we're multiplying a binomial by another binomial. A binomial is an algebraic expression that contains 2 terms. A monomial contains 1 term, a trinomial contains 3 terms, a polynomial contains many terms. So we need to use the FOIL method here. So let's begin by multiplying the first terms. 2x by 3x. 2 times 3 is 6. X times x is x squared. You need to add the exponents. 1 plus 1 is 2. Next we have 2x times 2. And so that's going to be 4x. Negative 5 times 3x. That's negative 15x. Negative 5 times 2 is negative 10. Now our next step is to combine like terms. And so those 2 terms are similar. You can't combine these 2 terms because x and x squared are different. 4x minus 15x is negative 11x. And so the answer is 6x squared minus 11x minus 10. And so that correlates to answer choice B. Number 3, which of the following is equivalent to the expression shown below? So we have 2 over 5 plus 4 over 7. How can we add these 2 fractions? What we need to do is get common denominators. The top number is the numerator, and the bottom number is the denominator. And right now, as we can see, they're different. So we're going to multiply the first fraction by 7 over 7. And we're going to multiply the second fraction by the other denominator. So that's going to be 5 over 5. And if you do this, you're going to get common denominators. So 7 times 2 is 14. 7 times 5 is 35. And then 4 times 5 is 20. And 7 times 5 is once again 35. So now that we have the same denominator, we can now add the numerators of the 2 fractions. 14 plus 20 is 34. And so the answer is 34 over 35, which corresponds to answer choice C. Number 4, calculate the value of the expression shown below. So in this case, we need to use order of operations. Perhaps you heard of the expression PEMDAS. Please excuse my dear Aunt Sally. And it tells us the order in which we have to perform mathematical operations. P has the highest priority, which stands for parentheses. E is for exponents, M is for multiplication, D is for division, A is for addition, S is for subtraction. So what this tells us is that we need to work with the numbers inside of the parentheses first. 7 minus 4 is 3. Next, we can focus on the exponents. So what is 3 to the second power? 3 to the second power means that we are multiplying two 3's together. And 3 times 3 is 9. 2 to the fourth power means that we're multiplying four 2's together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. Now at this point, should we multiply or should we subtract first? Now according to the order of operations, we need to multiply before we subtract. 5 times 9 is 45. 3 times 16 is 48. Now we can subtract. 45 minus 48 is negative 3. And so we can write our answer in the box. And that's it. Number 5. A circle has an area of 81 pi. What is its diameter? Let's begin by drawing a circle. Let's also draw the center of the circle. The distance between the center of the circle and any point on the circle is known as the radius of the circle. The diameter is basically twice the length of the radius of the circle. So the distance between any 2 points on a circle, where those 2 points, if you draw a line between them, it passes through the center, that distance is also the diameter. But what you need to know is this. The diameter is just twice the value of the radius. So in order to calculate the diameter, we need to calculate the radius of the circle first. Now we're given the area of the circle. What formula can we use? You need to know this formula. The area of a circle is equal to pi times the square of the radius. Now we're given the area, it's 81 pi. So let's calculate r. Let's begin by dividing both sides by pi. And so we could cancel pi. Thus we have 81 is equal to r squared. Now to calculate r, we need to take the square root of both sides. The square root of 81 is 9. So now that we have the radius, we can calculate the diameter. So the diameter is twice the value of the radius. It's going to be 2 times 9, which is 18. And so this is the answer. Answer choice E. Number 6. Which of the following is equivalent to the expression shown below? So here we need to subtract two polynomials. Notice that we don't have a negative sign or any number in front of the first expression. So we really don't need to write the parentheses. We can get rid of it. On the right side, we do have a negative sign in front of the second polynomial expression. So we need to distribute that negative sign to these three terms. So it's going to be negative 5x cubed plus 7x, because we have two negative signs, and then plus 5. Now our next step is to combine like terms. These two are similar because they carry the term x cubed with a coefficient in front. So we have 8 minus 5, which is positive 3. These two are not similar. They are not like terms. So we cannot add them. All we can do is just rewrite them. Now, these two constants, they are like terms. They're just numbers. Negative 9 plus 5 is negative 4. And so this is the answer. It's 3x cubed plus 5x squared plus 7x minus 4. Number 7. What is the surface area of the cylinder shown below? For this problem, all you need is the formula. The surface area of a cylinder is equal to 2 pi r squared plus 2 pi rh. And you need to be able to identify the radius and the height of the cylinder. 7 is the radius of the cylinder, 12 is the height. So all we need to do in this example is replace r with 7, and then replace h with 12. And then we just have to do the math. 7 squared is 7 times 7, which is 49. 7 times 12. 7 times 10 is 70. 7 times 2 is 14. If you add 70 and 14, that will give you 84. Now, 2 pi times 49 is 98 pi. And 2 pi times 84. 2 times 8 is 16. 2 times 4 is 8. So this gives us 168. And now we can add 98 and 168 together. And so that's going to give us 266 pi. And so this is the answer. For those of you who want to review the old school addition, you could also do it this way. 8 plus 8 is 16. So you write the 6, carry the 1. And then we have 1 plus 6, which is 7. 7 plus 9 is 16. Write the 6, carry the 1, and then 1 plus 1 is 2. And so you get 266, which means C is the right answer. Number 8, multiply. So how can we multiply these two fractions? One way of doing this is to multiply across. You can multiply 21 by 72 and 40 by 49. However, this is just a longer way of doing it, because 21 times 72 is going to give you a big number, and then you're going to have to simplify the fraction. So let's focus on a better way, a much easier way of doing this problem. It's best to break down these numbers into smaller numbers. 21, for instance, is 7 times 3. 40 is equivalent to 8 times 5. We can replace 72 with 8 times 9. And 49 is 7 times 7. So make sure you know your multiplication tables. Now, you want to break it up in such a way that you can cancel a number